Good morning, stat kiddos, or whenever you're watching this video. I am filming it at 12:30 in the morning, so I'm trying to muster up as much enthusiasm as I can, even though I'm running off of 5 hours of sleep from the night before. Anyway, so I hope you guys are doing great, and I know a lot of you guys are involved in a lot of classes, a lot of AP classes especially, and you guys are probably booked and really busy. So I just wanted to explain we're doing well with our pace. We're getting through this material. I think you guys are doing really well. I like that I'm able to give you guys the solutions as well. So I'm able to give you guys even more feedback than I was giving my kids last year. And half my kids passed the AP test the last 2 years. So things are good. Things are going well. I do want to make some changes to improve just the accessibility that you have with me. So every school day at 1 o'clock, we'll be doing a live office hours for statistics and AP statistics. And yeah, so we'll start out just answering your questions at 1 o'clock, and we'll go from 1 to 2. It's come and go format, so just whenever you can stop by. If you could join at 1, that would be better. That way, if you have questions, I don't have to answer the same question twice, but you're welcome to leave whenever you would like. And after we're done working through all the questions over stats, you guys are free to hang out for the rest of the hour. We could socialize. I could tell you guys Mr. Murphy stories or whatever. I know you guys are really busy, and so you're probably just going to want to ask your questions to go, and I totally respect that. My honors geometry kids, they stayed and talked for a really long time, but it was good. It was good to see their face, good to hear their voices, if nothing else. So I'll see you guys at 1. Again, it's not mandatory, just if you want to get some extra interaction with the teacher and ask your questions direct, I think it'll be really good for us. Okay, so let's go ahead and get started. I'll try to make this pretty quick today. So we're going to just do a quick review, just describing distributions. The center, we look at the mode. So this is unimodal because it has one clear peak. Bimodal, which usually happens when we're dealing with differences between subgroups in data, such as male and female. Multimodal, that can happen as well. It's interesting when it does as well. Then uniform is pretty well straight across the board, with no clear mode. When we have unimodal data, we also look and see if it's symmetric. So if it's unimodal and symmetric, like if we fold it over, then we're able to use a bell curve to approximate it, which will be really powerful. Today I'm going to teach you guys how to do mean and standard deviation, and even to calculate standard deviation by hand, which today I'm pretty sure will be the only day we ever calculate standard deviation by hand, because it's kind of tedious. But I think if you do the calculations by hand, we'll do it together, by the way. You have more of an appreciation of what the calculator is doing, and you have a mental understanding of how the standard deviation is calculated in the first place. Okay, so once we have the mean and standard deviation, we can use a bell curve to approximate data that looks like this, and that's where we'll get into the next part right after this chapter, I think chapter 5, which is really important. So anyway, data that looks like this for statisticians is really good, and we can use some powerful models to model this data. Okay, when it's skewed to the left, we follow the tail that tells us it's skewed to the left or skewed to the right. We follow the tail to describe if it's skewed. All right, then outliers is gaps is whenever it's separated. We have two groups of data separated by multiple empty bins. Okay, so if it was just one of them, it wouldn't be considered a gap. Okay, also out here, this is not considered a gap because it's not two groups of data. This is considered a possible outlier, which we learned yesterday how to calculate to do the left and the right fence, or the upper and lower fence test. To decide whether or not it actually is an outlier. So we multiply the IQR times 1.5 or 1.5 times IQR, and then we add it to the third quartile for the right fence, and we subtract it from the first quartile for the left fence. Anything beyond those fences would be considered an outlier. All right, and over here, these are not considered gaps, or they could be potentially outliers if we had our interquartile range, but 1.5 times that IQR is probably going to include it. So it's probably not an outlier, but we could test that. There's another way to calculate outliers or anything that's unusual when we're dealing with standard deviation, when we have unimodal and symmetric data as well. All right, so the difference between the median and the mean, and this is measuring the center of it, okay? We also have the mode, mean, median, mode, right? So we would use the mode if we were describing like bimodal data here. We would describe the two most frequent categories here for blood pressure. So people in the normal range tended to have about, let's say about 95 or something like that for their blood pressure, or from anywhere from 85 to 95. I don't know what that is. You'd have to read it. And then anyone who had high blood pressure would typically have a range from 125 to 135 or something like that. Okay. All right, the median is the 50 percentile, which means we have equal area on the left side as we do the right side. The median is impervious to outliers and skewed data. The reason for that is it doesn't matter where this point is, no matter how close it is over to the rest of the data or how far off it is to the left, even off the page, it's still, we're looking for the 50th percentile, okay? So that how far off your outliers are is not going to impact the 50 percentile. We just have to have equal area on the left side as we do the right side. So the median is durable, I guess is a good way of putting it. It's not impacted by skewedness or by outliers. So anytime we have skewed data or outliers, or anything else, we will use a median. All right, then the mean, which is the balancing points, the average. Okay, so if you put this mass and you separated the mass and you put it on a pivot, it would balance at the mean, which is kind of cool. So that's means are pretty useful, but this mean is going to be pulled to the left by this outlier or potential outlier over here. Okay, and the whole thing being skewed also means that the mean is going to be skewed to the left and it's less than the mean that we would have when we were, or the center we would have if we were using the median. Okay, so we only use mean and standard deviation with unimodal and symmetric data that looks like a bell curve. Okay, something like this. For everything else, we will use median and IQR, interquartile range. Okay, so for this distribution here, what would we use for the center, the mean or the median? So if we look here, it does look unimodal, kind of skewed, but roughly symmetric. Okay, it's skewed, but the real issue, the real issue is the outlier way over here. This outlier is going to skew or to pull the mean to the right, far from where the actual center should be, which is with the mode. Okay, so the median would be a better measure for the center, and the interquartile range would be a better measure for the range instead of using standard deviation. If we calculate the standard deviation with a deviation way out here from the mean, there's going to be a huge deviation from this one outlier, and it's going to mess up our average deviation, which is our standard deviation. Spoilers. Okay, center, what about for this one? All right, so on this one, let's say the median is right here. So we have equal area on the left and on the right. The mean, because the data is skewed to the right with this possible outlier, the mean, the balancing point is going to be somewhere off to the right. Okay, so it was pulled to the right by the skewed data and most importantly by this outlier over here. So which one's the most appropriate? We would use the median because it's not unimodal and symmetric. Now it is unimodal, but it's not symmetric and it's got an outlier, so it won't work. All right, the reason we don't use range for the spread is range is drastically impacted by outliers. Okay, so this outlier of the number of states that I visited changed our range from what would have been 17 all the way up to 24 just from one outlier. So we would not summarize this data with the range for our spread. We never use range actually. We use interquartile range and standard deviation. All right, so your quartiles, just a quick review on this one. It's the percentile ranks. So the lowest one would be the 0 percentile. The first quarter is the 25 percentile. The 50 percentile means half the data is below it and half the data is above it, right? 75 percentile, like if you score within 75 percentile on your ACTs for score or something, that means that you scored higher than 75% of the national average or state average or school average or whatever. Then the 100 percentile is going to be the top score, okay? So that's your 100%. That's how they break it down. It's also called a 5-number summary where you give the minimum, first quartile, second quartile, third quartile, and the maximum. The second quartile is also called the median. You can also write it as Q2 sometimes if you want as well. All right, so the interquartile range is going to be the middle 50% of data. Okay, so the middle half of the data is going to be interquartile range, which is typically going to be slightly smaller than a standard deviation, even for unimodal and symmetric data. How I know that, that'll take you a while to figure it out, but it's okay. Spread. So another way we could do, when we have unimodal and symmetric data without any outliers, we can use standard deviation, and that allows us to use a bell curve, which is really, really powerful model. So what we do is we take the sum. This is a sigma. It's Greek letter, capital Greek letter sigma. You probably are familiar with that if you've taken some higher level math. So the sum of the deviations are how far each data point is from the mean. Okay, so how far did it deviate from the mean? So we square those deviations so we don't have negative and positive ones. It's kind of how we fix that. Then we divide it by n-1 because we're dealing with a sample from instead of an entire census of a population, which is important, but that's okay. We'll get into that more. And then we that'll give us the variance. So the total amount of variance or variation that we have in the data is the sum of the square deviations divided by n-1. But to go from variation, which is in squared units, to standard deviation, which is in our normal units, like whatever units are on the x-axis, we would take the square root of the variance. Because we squared it here, we're going to take the square root to get it back to the standard units, and that's called the standard deviation. So what a standard deviation is the average deviation each point is from the mean. It's that simple. But the way we calculate it, we have to do, it's kind of more like the Pythagorean theorem. We have to square it and then take the square root of it when we're done. That way we can account for the negative values. So what does a standard deviation mean? It means the average spread, or the average deviation from the mean for each value. Okay, so let's calculate some standard deviation. So we're going to have 5 different groups of data, and these are clearly ideal data sets, okay, so that you can clearly see what happens as we change these data sets. So our first group, all 5 of them were 10, so we got 5 10 dots stacked here. That's group 1, okay. The next one, we have 3 10s, 1 8, and a 12. So we see our 8 here and our 12 here. So what's happening from our first group to our second group? The spread is increasing, right? Is that going to increase the standard deviation a lot? Well, it's going to start out with a standard deviation of 0, because there was no deviation from the mean. It was 10 every single time. There's no deviations. And now we're going to have some spread. So if you're going from 0 to anything, yeah, sure, it's going to increase by quite a lot. The next one is going to have a 0. So now our low one over here is way over here at 0. And then we have 3 10s and 20. So 10, 10, 10, and 1 over here at 20. Now we still have 3 that are exactly the mean, but now our deviations are further apart. Instead of just being a deviation of 2 from the mean, now it's a deviation of 10 from the mean. So these 2 clear outliers, 10 or 20 and 0, are going to increase the standard deviation drastically, and we'll see that when we calculate it. All right, group 4, looks like we have one at 0, we have one at 8, then we have one at 10, and then 12 and 20. So now we've got even more spread. We still have our outliers that are pretty extreme, but instead of having all 3 that are the mean, we have the spread from here as well being added to it, okay? Then on group 5, we have 0, we have 2, and then 10, and the same thing. You'll notice that I'm making it symmetric on both sides. It makes our calculations easier. So that one has the most spread so far. As we keep going, we're increasing the spread, of course. And then the last one's going to be 2, and then 6, and 10, 14, and 18. So that one's actually going to have less spread than group 5. Of course, you can see the deviations are not spread as far close to the extremes. Okay, so now that we've graphed that out, the next thing we're going to do is calculate the deviations, and I'll come back to that table here. So for group 1, the scores were, we had 5 10s. The deviation will be the next group. Well, the mean in this case, when we calculate the average of 10, the mean is just going to be 10, right? Because the average of 10, 10, 10, 10, 10 is going to be 10. So our deviations, how far are we from the average? Actually, let me go back here real quick. For all of these, because they're symmetric, the average is actually going to be 10. So I'm going to graph that out for you real quick so you can see. So our average is going to be this 10 here. So what we're asking is how far are these deviating from the average. I'm actually going to graph this and say this is x bar, which is an average, okay? So how far are our deviations? All of our deviations are 0. Okay, so let me go to the next one. So our deviation is going to be 0, 0, 0, 0, 0, because it wasn't deviating from the mean. So when we square those deviations, they're still 0. No big deal. The sum of the squared deviations for this one is going to be still 0, right? The sum of the deviation squared divided by n minus 1. So anything divided by, the n, by the way, is a number. Our sample size, which is 5. 5 minus 1, it was actually 6 groups, right? No, 5. Oh, because our sample size is 5. There's 6 groups. It's something totally different. All right, so 5 minus 1 is 4. So divide 0 by 4, it's still going to be 0. And then the square root of 0 is 0. So our standard deviation is 0. Our variance, which is what this one's going to be, is equal to 0. So variance is 0. Standard deviation is also 0. You also see standard deviation written as S of x whenever it's created from the calculator. Okay, let's look at group 2. Now, our 8 was deviating from our mean. It went over 2. So this part here, this is our deviation, is 2. And the other one, sorry, it's actually a negative 2, is deviating from the mean, negative 2 and positive 2. So hopefully you can see that graphed out. So our deviation is going to be negative 2 because it was 2 less than the mean. These are going to be deviating 0, and this is a positive 2. When we square the deviations, it's going to be 4, 0, 0, 0, 4. Okay, now we're getting into something. The sum of the square deviations is 8 divided by 4, which is our n minus 1, is going to be 2. The square root of 2 is going to be 1.73, I think something like that. Let me pull up the calculator real quick. I should have that one memorized. All right, so 2 caret 0.5. Oh, my bad. 1.73 is something different. It's probably the square root of 3 is what I was thinking. We use the square root of 3 more in geometry than we do the square root of 2. All right, so our standard deviation is going to be 1.41. So this is going to be 1.41. Our variation is going to be equal to 2. Okay. All right, now let's do group 3. The 0 is going to deviate from the mean a total of negative 10, right? So that has a deviation of negative 10. And this one over here is going to deviate from the mean. The 20 deviates a positive 10 because it was 10 above the mean. So I'll fill this in pretty quick for you. So we got negative 10, 0, 0, 0, positive 10. Squaring that's going to give us 100. These are all zeroed out, right? And then 100. Adding the deviation squared is going to give us 200. Then dividing that by 4 is going to give us 50. And then the square root of 50, let's say for all practical purposes, is about 7. Because I know, actually, it's 7.07. How do I have that memorized? I'm pretty sure I memorized that from last year. If I'm right, that's I need help. I'm such a nerd. Okay, that's good for you. All right, 7.07, group 4. So that's going to be a deviation of negative 2 and also negative 10. And this is going to be a deviation of 2 and a positive 10. So pretty simple. Just going through. If you enjoy crunching numbers like this, you should really think about a career in math because this is incredibly enjoyable to me. And I know you're probably more likely just watching me do it and filling it in on your paper, but that's totally fine. You're a part of the process. This one I think is a typo. That should actually be 12, in case you were wondering, because we do want to keep it symmetric. Otherwise our means are different and you have to calculate each one of them separately. All right, so add those together. That's going to be 208 for our squared deviations. 208 divided by 4, that's going to be 52. And then we want to take the square root of 52, which I don't have memorized because I don't have problems. Okay, so 7.2 is our standard deviation. Okay, so notice our standard deviation went from no deviation, okay? So we had a standard deviation of 0, okay? Then we had a standard deviation of, what was it, 1.41? So 1.41, okay? Then we had a standard deviation of 7.07, and now we have a standard deviation of 7.2 something. Yeah, and then it's going to be even bigger, and the biggest one is going to be this one here. All right, so doing this one, we have 10, which is 100, 2, which is going to be 8 and 64, 0, 0, 8, 64, 10, 100. Adding those together is going to give us 328. So square deviations is 328. I got to divide that by 4, which is our n minus 1, and then take the square root of that. So that's our total variation that we have. And then when I take the square root, so caret 0.5, it's going to be 1.3. Did I do something wrong? Oh, I forgot to do, yeah, okay, so 328 divided by 4, that's our variation. So we have a variation of 82, and then we take that to the square root, which is going to give us, okay, 9.05. So that, I think, was 82, then 9.05. And of course, because that's close to 81, it's going to be about 9. All right, last one we have. I know this is taking a while. I apologize. So this is going to be deviating by 6, 4, 2. Nope, this one should be 10. That should be 0. And then 4. And actually, let me double check. I might have all kinds of problems on this one. Yeah, so they deviate by 4 and 8. So this is actually 2. So that deviates by 8. Sorry about that. All right, so 64 and 16, which is 70. So 70 and 70 is going to give us a total of 140. 140 divided by 4 is going to be 35. Yeah, so our total variation in this case is 35. Then we take the square root of 35, which is going to be, I'm just going to estimate about 5.9 because it's close to 6. All right, so go back here. We had this one, which had a deviation, standard deviation of 5.6 or 9.06, and then this one was about 5.9. All right, so you can see the spread and the total differences in the standard deviations. Okay, so look over that, take some time, just study it, make sure you understand what's going on. As I said, if that wasn't boring to you, if you didn't find that just the most exciting table you ever filled in, then that's okay. That means you're normal. And if you enjoyed that, I'm not going to say there's anything wrong with you, because there's nothing wrong with me. And I'm just a beautiful little butterfly. That was terrible. I'll work on that, but it's okay. I didn't want to be too loud because I didn't want to wake up my neighbors. But anyway, cool, and there's nothing wrong with you. But if you didn't want to ever do this again, the good news is you don't ever have to do it again. We're only going to calculate by hand once, and we just did it. Okay, so I'm going to help you with most of your assignment, so we'll get that going. Not doing too bad on the link to the lecture. So number 11, heart attack stays. The histogram shows the length of hospital stays in days for all the female patients admitted to the hospital in New York during 1 year with primary diagnosis of a heart attack. From the histogram, would you expect the mean or the median to be larger? So remember, the median is not impacted by skewedness, nor is it impacted by outliers. The mean is drastically impacted by skewedness and outliers, just like we saw with our graph over here. When we had these far outliers way out here, even when there was just one of them, that increased our standard deviation from 1.4 to 7 because of the outliers, because they were so far deviating from the mean. Okay, so the skewedness that we're going to have here, and these parts that are so far away from the mean, is going to increase our standard deviation a lot. It's also going to pull the mean, the actual average, to the right as well, because it's going to be skewed to the right from the median. All right, so which one would you expect to be larger? I would expect the mean to be larger because it's going to be impacted and skewed by the data that is skewed to the right. Okay, and write a few sentences describing the shape, center, spread, and unusual features. Okay, so the shape here, you might say unimodal because there's one clear mode here, but there's actually two. So it looks like the most often categories are either that they stay for one night or one day. That's going to be this the lowest possible amount, right? So they either stayed overnight from a heart attack. I guess they forced them to stay overnight. No one was outpatient for that day. Or it looks like about 7 days. So you're either going to fall into two categories or two modes. Either you're going to just stay overnight, they're going to release you, or they're going to keep you for a week. That seems to be kind of standard. There were some people that were less than a week, and there were obviously some that had to stay even an entire month. So just depending on what happens with the heart attack. Maybe they have to do a surgery or open heart surgery or bypass or something. All right, so data skewed to the right. All right, it's bimodal with two modes, either 1 day and 7 days. The interquartile range, if I'm guessing, the quartiles are probably going to go from, I don't know, about 5 to 15. So this is the first 25% of data, middle 50%, and the last 25%, which would mean an IQR is roughly 10. That's just an estimate. It's probably higher than that because this one's going to be even further to the right, and that one's probably further to the left as well. But it's just an estimate, and without any unusual features such as gaps or outliers. There's no gaps in the data between two groups of data. Also, these are potential outliers. You could say they're potential outliers, and we'd have to do a test in order to determine if they were actually outliers or not. All right, which summary statistic would we choose for the center and the spread? So since the data is not unimodal and symmetric, and because we have possible outliers and it's skewed, we're going to use the median and the interquartile range because it's not going to be drastically impacted by the skewed data and the potential outliers. Okay, and you can read that if you want. All right, 42. So on this one, you're going to have to use a calculator. I'm still working on get you guys calculators. Talk to Snett. She's got to talk to some other AP teachers to get a do a day without just me doing my own thing and just like having you guys message me and then I don't know. I'm just trying to do it on the same day. That way I don't have to be available the entire day, and that other teachers can help me. But we'll get it figured out. Until then, if there's any problems, you have to be able to use a calculator. I'll show you on the video so you'll know how to do it, okay? So Wayne Gretzky in exercise 40, which I think we did yesterday, you examine the number of games played in hockey by the great Wayne Gretzky during his 20-year career in the National Hockey League. Here are the number of games that he played during each one of those seasons. Insert the following data in your calculator for list 4. I don't know why I decided to do list 4. I guess we had stuff saved for list 1 through 3. But to get to your list, you're going to go to Stat and then Edit. And then I put all that data here in list 4 for you, which is very nice. Okay, then the next thing we're going to do is use the histogram, use the calculator to construct a histogram. So I'm going to go to second, Stat Plot. I'm going to turn on the first plot and do a histogram. I'm going to do list 4. So I would hit second 4, and that's going to be the blue L4, list 4. Okay, so apparently I clicked the wrong one. Frequency list, you can keep that as 1. Let me go to, what was the error? Oh, because I did it twice. There we go. And then to graph it out, we're just going to hit zoom 9. Now I had my second plot turned on as well. Sorry, my nose was itching. So I graphed a modified box plot at the same time. So if you look here, that's the second plot was turned on for list 4, and it's a modified box plot. We never use one that's not modified because we always want it to test for outliers. Anyway, so whenever I hit zoom and 9, that's going to be zoom stat. You can see it on the bottom there. That's going to graph it out for me. Now, the windows will always be filled in for you, but to make it easier to read, I'm going to go in and change the window. So 45, I'm going to go to 90, and I'm going to go by 5s, right? That's just going to make it a whole lot easier to read. And now whenever we go to trace, our bins are going to go from 45 to 50, and then 50 to 55. You see why, okay? So that's just a trick. It's good for you. Okay, so I went ahead and graphed it out here. So now that we see the histogram, we're not just looking at all this raw data, which is really hard to interpret. We see there's some low values like 45. He only played a half a season or whatever. There's a few other outliers. Or that was the main one. 64. That one's clearly smaller. Anyway, so that's it. And that might have not copied right. It doesn't matter. All right, so use your calculator to graph the histogram of the distribution. When you use the median or the mean to describe the center of the distribution. So again, because it's not unimodal and symmetric without outliers, we have to use the median and the interquartile range. And the reason we're going to do that is because these outliers are going to drastically increase the standard deviation, because the deviation from the mean is going to be really high for the value or the few values that we had on the low end, okay? All right, so sort the data in ascending order. So hit stat, then sort A for ascending for the list 4. So let me show you that real quick. So I'm going to quit out of this, and I'm going to go to stat, sort ascending, which is the second option. And then I'm going to do list 4, so second 4. And it's going to sort the data in ascending order. So if I go back to stat and edit, you'll see list 3 is the raw data unsorted. List 4 is now sorted. So that was nice. We're going to use this sorted data to be able to calculate the median. Again, you won't need to calculate medians on your own. I mean, they will ask you to do stuff like that on the ACT, so you need to know how to do it. It's kind of nice if you put the list in there and do ascending order. So, hey, there's an ACT thing. Oh yeah, by the way, my students last year, after we finished the first unit and they took the ACT, they understood all. Typically there's like 3 to 4, sometimes even 5 problems on the ACT about statistics. They said they understood all those problems, and those were the easiest problems for them after they took the first unit of stats. So if nothing else, taking this class, at least the beginning, will help you guys out on your statistics for the ACT, which is kind of cool. All right, so we want to find the median. So if there's a list size of 20, if I go all the way to the bottom, it's 20. See how it says L4, list 4, 20? That means the median is going to be halfway between, so if I go to 10, the median is going to be halfway between 10 and 11. So 10 and 11 is going to be 79 and 79. So we take the average of that, which would give us 79, of course. So the median is going to be 79. Now, typically, we would calculate the median and the quartiles and stuff by just doing stat, and we would go over to calculate one variable statistics, frequency list. I think I can leave that blank. Yeah. and that's how we get all of our information. If you read the notes on yesterday, I actually go through and tell you what each one of those mean. I won't do it here. But the X bar is the mean, and the ones we're interested in for the 5-number summary are going to be the last 5 right here. So the median, of course, is 79, which is exactly what we calculated, okay? But instead of having to go through the list, sort the list, and do the quartiles, you just put it in the calculator and it does it for you. All right, so part C, without finding the mean, which we just did, so would you expect it to be higher or lower than the median based on the shape of the distribution? Well, if we see our distribution is skewed to the left with possible outliers, that means that our mean is going to be skewed to the left as well. So it's going to be lower than 79. All right, so since the data is skewed to the left by the outliers, I expect the mean to be skewed to the left as well. So it's lower than the median and would not be a good measure for the center because it's not unimodal and symmetric. Also, the standard deviation would be too large as well because the large deviations that we have from the means of the outliers. So we would use median and interquartile range for this one because it's not unimodal and symmetric and without outliers. So that's really important. So let me show you that. So when it's unimodal, symmetric, and no outliers, then we would get the mean and standard deviation, which, by the way, I just copied those from here. So our mean is going to be the 74.35 with standard deviation, the S of X. This is for population. This is for a sample. We always have samples, by the way. It's going to be a little bit larger than the population because there's more variation in the degree of freedom we lose. It's going to be 10.53 approximately. And then for the median and IQR, for the interquartile range, we would subtract 80 minus the first quartile is 73.5, which is 6.5. Okay, so when we have unimodal and symmetric with no outliers, we use mean and standard deviation and a bell curve, really. And when we have anything else, there's MasterCard. I'm just kidding. Could not do that joke. It was there the whole time. Okay, whatever. I'll do the same joke next year in case you're wondering. So the median is going to be 79 with an interquartile range of 6.5. So look at the difference between these two. What did this outlier and skew data do? It took our median of 79, which is an appropriate measure of the center, and now it's lower. It got skewed to the left 5, okay? Then look at our standard deviation. Instead of having an interquartile range, which is typically slightly smaller than the 68 percentile that we would have in the middle with a standard deviation, anyway, well, it's kind of cool to know that. It's still a lot larger because of the deviations that we had from those few seasons that he didn't play a full season. He only played half because of injuries or whatever. All right, so the reason why we do not use mean and standard deviation for skewed and skewed with outliers or anything else is because our means are going to be drastically impacted by outliers and skewed data. Same with the standard deviation. Median doesn't matter where this value was. If it was here or tucked up right on the left, the middle 50% still the middle 50%. Okay, and the interquartile range, it doesn't matter what's going on in the first quartile or the last quartile. The range in between those two quartiles is going to be pretty stable, and that's why the IQR and the median are always good to use for everything else, unless we are able to use a bell curve with unimodal and symmetric with no outliers. All right, I'm 33 minutes. I'm going to stop talking. I am sorry it got a little bit dry when we got to calculating by standard deviation by hand, but hopefully graphing that, even though it wasn't that beautiful, hopefully you understand what's going on and you have a general good grasp of what a standard deviation is. As I said before, standard deviation is the average deviation for any data set, okay? And I went through 2 college courses of statistics using the word standard deviation and variance. I mean, I knew it was the square root and I knew all that, okay? But I couldn't tell you in layman's terms, what does standard deviation even mean? It's the average deviation for a data set, okay? And we only use it, of course, when we have unimodal and symmetric data. Okay, so you're already better off than I was after 2 college courses in statistics. So hope you guys are enjoying the class. If you have any questions or if you just want to hang out, it's totally fine. 1 o'clock, I'll post a link about 15 minutes early or whatever, or I'll probably post it with assignment, like I said. But I'll see you guys at 1 o'clock. You don't have to turn on your mics, even though you can ask your questions through the chat window. The chat stream, and you don't have to turn on your cameras either if you haven't did your hair yet, or whatever. So I know, because half of you or more than half of you would have to do your makeup first and all that stuff. So I understand. It's okay. I mean, I don't understand because anyway, I'll see you guys at 1 o'clock. Have a good day. Bye.